Dear Sapdolf, could you tell me today about work processes in SAP?
Sure, why not? As usual, it will be practical and specific. I'll try to show you in the system what you know from boring architecture diagrams, so that you understand how to relate it all to each other. I will focus on S/4HANA, of course, while the operation of work processes has changed slightly over the years. So if you have an older ABAP system, you will also learn something useful.
Will this be a lecture for beginners or for advanced audiences?
Well, it is natural that if you want to learn something about work processes, you rather start your adventure with SAP. However, I will try to present the topic very comprehensively so that everyone will find something for himself. I will show various mechanisms both in the SAP system but also in the operating system. I believe that the most important thing in understanding is to link facts, so we will look at the topic from different perspectives. No worries, we will learn the subject step by step so that everyone can understand.
Where do we start?
Obviously from the boring architecture diagrams to locate where the work processes are. Let's first take a bird's eye view of the system. I'll discuss them quickly with a bit of simplification. At the very top, we have the presentation layer, which houses the software that is used directly by the user, whether it is the SAP GUI or a web browser. The request from the user software goes to the application layer, which processes it using its mechanisms. In the past, you could even say that in this layer you find the software responsible for all the business logic, although S/4HANA has changed that a bit. For us, the most important thing is that there are ABAP hosts in this layer, which we will deal with. In particular, we will be interested in SAP application servers. At the very bottom is the database layer, where, in the case of S/4HANA systems, there is an instance of the HANA database. Yes, the names are similar, and this often causes a lot of misunderstanding. So let's remember that HANA is the database, which is in the lowest layer, while S/4HANA is the application layer.
Well, but where are the work processes?
Let's look at the diagram for a single ABAP server. This is a primary application server, but it differs from an additional server only in that we also have a central services instance on the same server. The components we are interested in are on each ABAP application instance. It is specifically dispatcher and work processes. Dispatcher is a manager that distributes work between SAP work processes. You could say it is a manager or rock planner. Work processes, on the other hand, are specialists who perform different types of work. There is a strict specialization among processes. There are different types of processes, and the dispatcher knows what type of task can be assigned to a particular process.
But where in the system can I see it?
Well, that's it. We finally come to the practical part. Let's start with transaction SM50. It shows all the processes in a given SAP instance. The first column is the process number, while the second column is the process type. DIAs are dialogue processes that handle the user's interactive queries. When these processes start running out, the user is forced to wait. And users don't like to wait. They get very irritated then. So it's worth monitoring the occupancy of dialogue processes. The second important type of process is BTC, or background processes, which are executed without user interaction. They perform heavier tasks, reports, for example, those that the user has ordered to be computed later, expecting only a printout at the end. Periodic tasks, including housekeeping, are also usually performed using background processes.
Should there be more dialogue or background processes in the system?
It depends. First of all, on the type of system load. Sometimes in enterprises, separate instances are created just for background processing to leave the servers for users very responsive and less loaded. Usually, however, servers are general purpose and combine different types of workers. There is no single type of proven method. Most often, some initial assumptions are made, and then the situation is monitored and the configuration adjusted if necessary.
And what other types of processes are there?
We also have SPO, or spool processes. These handle printouts, although not just for printers. Another type of process is UPD and UPD2. These are so-called update processes. They are responsible for writing changes to the database. They accept orders from other processes mainly dialogue ones, though not exclusively. They then perform asynchronous saves in the background.
Does the dialog process always use UPD to save something in the database?
No, if immediate confirmation of data writes is important, the programmer can perform synchronous writes without involving the update process. Update processes were created so that larger data writes would not slow down the system. The data to be saved can then queue up to the update processes.
Can I see somewhere this queue?
Yes, you can always check the queue in SM13 transaction. My system is a very small sandbox, so I don't expect any queue. On the other hand, it is good to know that this is a very important transaction for the system and business data. But let's return to our main topic, an SM50 transaction.
Awesome. How many are all these processes and what does it depend on?
It can be assumed that an instance has a fixed number of processes, although this is not entirely accurate. The system should be parameterized so that these processes are not in lack. Otherwise, queues and delays will arise, which, of course, in some cases may also be acceptable. But this already depends on the purpose and type of load on the system.
And where do you set the number of processes on the system?
This is determined by the instance profile parameters. We can view them by entering the RZ10 transaction and selecting the correct profile. Then, we select Basic Maintenance. In the Number of Work Processes section, we see the numbers of specific processes. On the other hand, we are usually interested in specific parameters. Then we enter the Extended Maintenance option. You can easily find the parameters responsible for particular types of work processes.
What if number of some type of process is not enough?
Then it is worth considering what is causing this. In the simplest case, it could be a bad configuration. You can increase the number of processes in the configuration if there are free resources on the server.
What kind of resources?
Every process consumes memory and CPU. Any configuration changes, therefore, should be cautious and may also require adjusting parameters related to memory handling.
What if we know that the configuration is good?
Then the problem may be bad sizing of the system. Perhaps the architect planned for too few resources, or the system grew, and no one planned to properly increase its resources. Consider that business can grow, and the volume of stored data can increase.
Is it then necessary to go shopping right away?
No, absolutely not. First of all, you need to make sure that this is definitely our case. You need to check what is taking up the processes. Maybe it is one program that has been modified recently, and the changes have made it very inefficient. Or maybe some user or group of users is using the program incorrectly. Or maybe the business is performing some extraordinary action that is perhaps suboptimally planned. You certainly need to start by analyzing current load and historical trends. When you see a spike, you should try to correlate it with transports or special activities.
I understand. We need to analyze case before any purchase. Optimization is better than adding resources. And what else can we take from the SM50?
That's right. Let's go back to our table because we've gotten a little bit too wordy. The third column is the process ID.
But we have the worker number already in the first column. Why this additional identifier is needed?
This is the process identifier at the operating system level. Because a process in SAP is a kind of abstraction layer that is physically executed by a process running in the operating system. At any time, we can take such an identifier and see what this process looks like in the operating system using the PS command. I will take an example dialog process ID and try to find it in the operating system. The process ID of the first dialog worker is 167198. And here it is, the first entry. I recognize A4H as my system ID, D00 as an instance number, and then path to my instance profile.
And could you show all the work processes on this server?
I can list them by analogy, looking for all processes containing dw.sap. The grep command will help with this, as usual. As you can see, the list is quite long. If you look closely, you'll notice that you'll find these PIDs listed also in SAP. For example, those with the ending 202, then 3 and 4.
And can we confirm the number of these processes?
Sure, no problem. I just need to eliminate grep from the results. And we can see that there are 16. It may seem interesting that the work processes alone on the system are 15, which is one less. Why? Let's recall for a moment the diagram I showed earlier. I said that we would be interested in both the work processes and their manager, called the dispatcher.
Is this 16th process just a dispatcher?
We can check this together. We can start from checking initial logs of the dispatcher. I go to work directory of my SAP instance. Here I have dev.disp log file, which was created during startup of the service. In the middle of the window, you can see process ID of the dispatcher. I can check the process with PS command. Yes, it looks exactly the same like work processes. By the way, this DW at the beginning is the abbreviation for disp plus work, which means dispatcher and work process. The PID of the dispatcher is also visible when I run SAP control command with function getProcessList. You can see 167191 at the end of the first line. This is disp plus work, which is dispatcher in running state. I can demonstrate one more thing to you. In the dispatcher log, you can find information on what workers were brought to life by it. I can see what process numbers were started and what IDs they got. If you compare, this is exactly the same as what we see in the SM50 transaction. I can even confirm that 15 processes were started. That's right, as many as you see in SAP.
Thanks. This is really interesting, but why are we actually interested in the processes in the operating system? Aren't the tools we have in SAP completely sufficient to support system and analyze problems?
More than anything, it is useful to understand how the mechanisms work and where the different worlds come together. Familiarity with Linux really helps a lot in the work of a basis administrator. Besides, whenever we suspect that performance problems are related to a lack of hardware resources, analysis at the operating system level is very helpful. Not only because here you can see most quickly what might be the bottleneck, but because of other programs. Consider that there are very often many more than just one instance of SAP running on a server. Often there are several SAP-related programs themselves, such as a database, diagnostic agent, host agent, or web dispatcher. Then a glance at the operating system can tell you where to start.
Is anything else important in the SM50 table?
Of course, each of these columns has its own meaning. For example, we have work process status. The most common are running and waiting. Waiting means that the process is free and waiting for tasks, like most processes on my small server. Running means performing some task. An interesting status is certainly on hold, because it means that the process is busy, but cannot perform the assigned task. Then in the next column, on hold, we have the reason for such a status. Often processes are waiting for a response to an RFC query, sometimes for a request to put a lock, to assign a document number, or to execute an operating system command. A special case here is prev, which indicates a particular large consumption of process memory and exclusion of process assignment for a single user. In general, the occurrence of on-hold status from time to time is perfectly normal. However, if it happens too often, it is worth looking into the causes.
And what is WP failures?
Let me do something irresponsible to present it to you. Before I do that, pay attention to the CPU time column. I will cause a crash by terminating work process number 0 from the OS level. I use the kill command to do this. Kill with process number requests process termination. After this operation, I need to refresh SM50 view. Now pay attention to 3 things. The CPU time has been reset to 0. The work process failure message has appeared, and in addition, the process ID is completely different. This means that it is a new process. After the previous one was gone, the dispatcher brought a new one to life. Let's see in the dispatcher's log whether this was indeed the case. Yes, there is an entry about the fact that work process 0 died, and also about the creation of a new work process. I'll take another look to see if I can actually find this new process using the PS command. Of course there is. Just remember that if WP failure count appears around processes, you should be interested in why. It could be a bug in the kernel, for example, or problems with the operating system running out of memory and randomly terminating processes, or many other things.
I think I know enough about the basics. Can we try to watch a process in practice?
Sure, I will run the program we will watch. I have prepared a simple report that reads the entire contents of the USRS02 table in an infinite loop. I'm running it with a dialog. There's not much to observe here, so I'll open a second session and go to the SM50 transaction to see if the process is visible.
That's right, I see it.
Sure, we can see that this is a dialog process currently running. The time column shows how long it has been executing. When I refresh the view, this value will change. The priority is high. In the name of program column, I can confirm that this is my task. As I scroll the view to the right, I can see additional details. The program runs in the SAP DALF user context, which is clear because I ran it. The client is 001 because that's where I'm logged in. A very important column is current action. It allows you to see what the program is actually doing. In this case, it's reading the database sequentially because the program is looping through the entire table. In the current action info column, you can see what table it is.
Wow, quite a lot of information about one process.
There may be even more. I can click on the process or select the WP info button to check the details. Right now I can see the overview, which is not particularly clear, so I'll go through the tabs. Memory details shows memory usage, which is very important information. However, when I refresh the view, nothing happens. The consumption doesn't increase because the program doesn't allocate new resources. This is a good thing. In the DB Statistics tab, I check what actions on the database have been performed since the program started. As you can see, these are only sequential reads, no inserts or updates. By the way, a large number of sequential reads is often a signal that the program or the operation of the database may be non-optimal. Although this, of course, depends on the task at hand. Runtime info shows the program call stack, which here is very simple because it is a single report. In application info, I can't find anything interesting for this program, while WP attributes shows some details about the work process itself.
And can you show some example of the background process?
Sure, a little unusual so that we can observe the on-hold status, by the way. I'll move on to the SM69 transaction, where external programs are defined. Here I have my Z sleep command, which refers to the SH sleep script. The script is very simple and sleeps for 120 seconds. So you can expect SAP to do nothing else but wait for this program to execute. I choose to execute the program as a job because we want it to be a background process. Scheduling allows for many different options, but I just want to execute it immediately. Now I go to the SM50 transaction to find the work process that executes the job. Here it is. As you can see, the WP status is on hold, and the reason is RFC response. This happens further because the program is executed by the gateway and the worker is just waiting for a response from the gateway. You can see exactly this when you go into the details of the process.
I am so wondering about one thing. In the diagram, you showed that there can be more application servers in the system, and we seem to see only the processes of one, right?
Yes, in my case, there is no difference because it is a small sandbox with one server. But there is an SM66 transaction where you have an overview of the whole system. As you can see, in my case, there is no difference.
Wow, thank you so much for the presentation. I didn't think so much could be said about such a basic topic as work processes.
We can talk about this all day long. In fact, what I have shown is just the tip of the iceberg. I haven't said anything yet about RZ04 transaction, where you can define operation modes with different number of processes depending on the day. This comes in handy, for example, when users work during the day and batch processing is done in the background at night. What's more, dynamic processes can also be defined in SAP. However, you have to be careful and always keep in mind the resources and memory settings.
Well, yes. And are there any more related topics that I should read about to be a good basis engineer?
Of course. Profile parameters related to the operation of work processes are very important. It is also worth reading about how memory is handled by different types of processes, because contrary to expectations, dialogue and background processes behave differently. You can learn the most when diagnosing problems in a real system.
Well, yes, but it's a high-pressure job.
This is true, which is why it's a good idea to learn beforehand about the tools that help in such situations.
What could you recommend as the most important, so as not to be surprised by a problem?
It depends. Every situation is different. However, if I were to think of something very important for real-world analysis, I would say trace work process logs.
Where can I find them?
First of all, in the SM50 transaction, you can select the right option. Administration, Trace, Display File menu. However, it is worth knowing that you can also find it at the operating system level in the work directory. This option is very useful if you want to trace the logs of all or selected work processes at once live using the tail command.
Tail, is that the snake command you talked about in the video about useful Linux commands?
Yes, exactly.
Indeed, knowledge of Linux is useful for a basis administrator.
Of course. Imagine the situation that you can't log into SAP because all the dialog processes are busy. What will you do then?
I'll probably check it from within the operating system, but then I won't be able to see what these processes are actually doing, what user or program has hijacked all the processes.
You can check this too using the dpmon program, which allows you to monitor the dispatcher from the operating system. You just need to specify the profile of the instance you want to monitor. The menu is quite rich. The Work Process Admin Table option shows data similar to SM50, although the capabilities are much greater.
I see that actually this topic can be talked about all day.
Yes, but you also need to know when to finish. Theory is important, while practical exercises are of utmost importance, so get to it.
Thank you very much for the lecture.
No problem. All the pleasure on my side. If you liked it, give me a like. And be sure to subscribe to the channel so you don't miss the next videos. Thank you for your attention, and until next time. May your system never run out of resources, and may your users always be consensual and kind.
Thanks, Sapdolf, for sharing your knowledge.